Welcome student. Today our topic is quadratic equation. It is lecture number 2. In last class we have discussed about the polynomial, and in polynomial we have discussed the linear polynomial, quadratic polynomial and cubic polynomial and biquadratic polynomial. After that we have discussed quadratic equation, in which we have find out the root of the quadratic equation. After that we discussed about the nature of the roots without finding the roots, actually roots of the quadratic equation. So, in this class we shall start the class with formation of quadratic equation. Suppose alpha and beta are the roots of the quadratic equation. These are the roots of the quadratic equation. Now, the equation will be suppose alpha is the root. So, x equal alpha will satisfy the quadratic equation, and x minus alpha will be the root, will be the factor of quadratic equation ax square plus bx plus c equals to 0, because alpha is the root. So, x minus alpha is the factor of this quadratic equation, and beta is also the root of the quadratic equation. So, x equal beta, and x minus beta will also be the factor of ax square plus bx plus c. Now, x equal x minus alpha and x minus beta are the factor of the quadratic equation. So, x minus alpha and x minus beta must be equals to 0. Now, we shall multiply x square minus beta x, now minus alpha x plus alpha beta. This can be written as x square minus alpha plus beta of x plus alpha beta equals to 0. Now, the quadratic equation will be x square minus sum of roots, because alpha and beta are the roots of the quadratic equation. So, alpha plus beta will be the sum of root, x square minus sum of roots of x plus product of root equal to 0. Suppose alpha and beta will be the roots. So, we can find out the equation by taking the sum of the roots and product of the roots. Now, let us take an example. Suppose there are two roots of the quadratic equation. The first root is 2 plus root 3, and the second root is 2 minus root 3. Suppose there are two roots of the quadratic equation, and these roots are in irrational form. So, we can find out the equation of the quadratic equation. Now, the sum of root will be alpha plus beta equal 2 plus root 3 plus 2 minus root 3, it will be 4. Now, we can find out the product of the root. It will be 2 plus root 3 multiplied by 2 minus root 3. Now, we can multiply these two. It will be a square minus b square, it will be 4 minus 3, it will be 1. Now, the sum of the root will be 4 and the product of root is 1. Now, we can find out the equation. Quadratic equation will be x square minus sum of root bracket x plus product of root equal 0. X square minus the sum of root is 4 and the product of root is 1. So, equation will be x square minus 4x plus 1 equals to 0. This will be the quadratic equation. Now, we can take another example in which roots are imaginary. Suppose roots are 2 plus I and the second root is 2 minus I. These two roots are complex, so we can find out the quadratic equation. Now, sum of root is alpha plus beta equal 2 plus I plus 2 minus I, the sum of root will be 4. Now, we can find out the product of the root alpha beta equal 2 plus I multiplied by 2 plus I, 2 minus I. Now, we can multiply 2 square minus iota square, it will be 4 plus 1 which is 5. Now, the sum of the root is 4 and the product of root is 5. Now, quadratic equation will be x square minus alpha plus beta of x plus alpha beta equal 0. Now, it will be x square minus the sum of root is 4 and product of root is 5 equal 0. Now, that is our quadratic equation. Now, we will discuss a transformation of quadratic equation. Transformation of quadratic equation. Suppose ax square plus bx plus c equals 0 is a quadratic equation. Now, we want to get a quadratic equation whose root is reciprocal of the roots of this given equation. Now, because roots are reciprocal, now we can put x equal 1 upon y. If we put x equal 1 upon y, then we will get the root of the quadratic equation which is reciprocal to the given equation. Now, put x equal 1 upon y, the equation will be a 1 over y to the whole square plus b 1 over y plus c equals to 0. Now, equation will be a over y square plus b over y plus c equal 0. Now, multiplying by y square both sides, it will be y square a over y square plus v over y plus c 0 into y square. It will be a plus by plus cy square equal 0. Now, the quadratic equation will be cy square plus vy plus a equal 0. Now, this is the quadratic equation whose roots are reciprocal of the given quadratic equation ax square plus bx plus c equal 0. Now, let us take an example of that. Suppose this is the quadratic equation x square plus 7x plus 12 equals to 0. Now, we can find out the root of that quadratic equation, but we are transforming this equation and we want to get that equation whose roots is reciprocal of that root without finding the roots of the quadratic equation. So, we will put x equal 1 over y. Now, the equation will be 1 over y square plus 7 of 1 over y plus 12 equal 0, and it will be 1 over y square plus 7 over y plus 12 equals to 0. After multiplying by y square, it will be 12y square plus 7y plus 1 equal 0. Now, let us check the root of the quadratic equation are reciprocal to each other. First of all, we shall find out the root of the quadratic equation x square plus 7x plus 12 equals to 0. After that, we will find out the root of the quadratic equation 12y square plus 7y plus 1 equal 0, and find out what is the relation between the roots. Now, the first equation is x square plus 7x plus 12 equals to 0. Let us try to factorize it. X square plus 4 plus 3 of x plus 12 equals to 0 by splitting of middle term. X square plus 4x plus 3x plus 12 equals to 0. X plus 4, x of x plus 4, now we are taking 3 in that, x plus 4 equals 0, it will be x plus 4 and x plus 3 equal 0. Now, the roots of this quadratic equation is minus 3 and minus 4. Now, we have found out the root of this equation is minus 3 and minus 4. Now, we shall find out the root of this quadratic equation. The root of this quadratic equation should be 1 upon minus 3 and 1 upon minus 4. Let us try to find out the root of the 12y square plus 7y plus 1 equal 0. 12 1 ja 12. Now, we are splitting the middle term. 12y square factor of 12 is 4 into 3. So, it will be 4 plus 3 of y plus 1 equals 0. 12y square plus 4y plus 3y plus 1 equal 0. Now, we can take 4y in first two, it will be 3y plus 1. Now, we can take plus 1, 3y plus 1 equals 0, it will be 3y plus 1 and 4y plus 1 equal 0. Now, the roots will be minus 1 over 3 and minus 1 over 4. The root of this quadratic equation is minus 1 over 3 and minus 1 over 4, which is reciprocal of the given equation. Now, we shall transform another quadratic equation whose roots are negative of the roots of given quadratic equation. Suppose ax square plus bx plus c equals 0. This is our quadratic equation. Now, we will find out another equation whose roots are negative of given quadratic equation. So, put x equal minus y. Now, new equation will be a of minus y to the whole square plus b of minus y plus c equal 0. Now, the new equation will be ay square minus by plus c equal 0. Now, it is the transformed equation. Let us understand by another example. Suppose x square minus 3x plus 2 equal 0 is a quadratic equation, and we want to get that equation whose roots is reciprocal of the whose roots is negative of the given quadratic equation. Now, we shall put x equal minus y. Now, the transformed equation is transformed quadratic equation will be minus y to the whole square minus 3 of minus y plus 2 equal 0. Now, it will be y square plus 3y plus 2 equals 0. Now, we shall check the roots. Now, first of all we will find out the root of x square minus 3x plus 2, and then after that we will find out the root of y square plus 3y plus 2 equals to 0, because we will check whether the roots are negative or not. Now, the first equation is x square minus 3x plus 2 equal 0. We will try to factorize it. X square minus 2 plus 1 of x plus 2 equal 0. X square minus 2x minus x plus 2 equal 0. Now, try to take out the common. X of x minus 2, here minus 1 of x minus 2 equals 0. It will be x minus 2 x minus 1 equal 0. Now, the roots will be x equal 1 and 2. Now, we shall find out the roots of the transformed equation, which is y square plus 3y, y square plus 3y plus 2 equal 0. Try to factorize it. Y square plus 2 plus 1 of y plus 2 equals to 0, y square plus 2y plus y plus 2 equal 0. Now, the roots will be, now when we will take out y from that, y plus 2 it will be, and now we can take plus 1, y plus 2, it will be y plus 2, y plus 1. Now, the roots will be y equal minus 2 and minus 1. Now, the roots of the first quadratic equation is 1 and 2, and the roots of this transformed quadratic equation is minus 1 and minus 2, which are negative to the first quadratic equation. So, we can say that we can find out the quadratic equation whose roots are negative to the given quadratic equation. Now, we will discuss the transformed equation whose roots are square of the given quadratic equation. Suppose ax square plus bx plus c equal 0 is the quadratic equation. Now, we shall find out the root of that another quadratic equation by putting x equal under root y. Now equation will be a under root y to the whole square plus b under root y plus c equal 0. It will be ay plus b root y plus c equal 0. It can be written as ay plus c equal minus b of root by squaring both sides. It will be ay plus c to the whole square equal b square of y. Now the equation is a square y square plus c square plus 2 ac of y equal v square y. Now the quadratic equation will be a square y square plus 2 ac minus v square of y plus c square equal 0. Now this is the transformed quadratic equation. Let us take an example of that. Suppose x square plus 7x plus 12 equals to 0 is an quadratic equation. Now we shall find out the transformed quadratic equation by put x equal under root y. Now it will be root y to the whole square plus 7 root of y plus 12 equal 0. Now it will be y plus 7 of root y plus 12 equal 0. It will be y plus 12 equal minus 7 root of y. Squaring both sides, it will be y square plus 144 plus 24 of y equal 49 y. Now the quadratic equation will be y square minus 25 of y plus 144 equals to 0. Now let us check the roots of these two quadratic equation, x square plus 7x plus 12 equals to 0 and y square minus 25y plus 144 equals to 0. First of all, we will find out the root of the first quadratic equation, x square plus 7x plus 12 equals to 0. That is our first quadratic equation. Now we can factorize by splitting of middle term, x square plus 4 plus 3 of x plus 12 equals to, now it will be x plus 4 x plus 3 equals to 0. The roots will be minus 3 and minus 4. Now we will find out the root of y square minus 25y plus 144 equals to 0. Now root will be y square minus 16 plus 9 of y plus 144 equal 0. It will be y square minus 16y minus 9y plus 144 equals to 0. Now take y as common, y minus 6, y of y minus 16. Now we can take out minus 9 in last two. It will be y minus 16. y minus 16 and y minus 9 equal 0. The root will be y equals to 16 and y equals to 9. Now, the root of this, the first quadratic equation is minus 3 and minus 4, and the root of this equation is 9 and 16, which is square of the given quadratic equation. Now we shall discuss the quadratic equations whose roots are common. So, let us take two quadratic equations. The first quadratic equation is a1x square plus v1x plus c1 equals to 0, and the second quadratic equation is a2 of x square plus v2 of x plus c2 equals 0. These are the two quadratic equations and whose one root is common, means there will be two roots of the first quadratic equation and two roots of another quadratic equation in which one root is common. Now, let us take alpha is the common root. Alpha is the common root, so it will satisfy both the equations. Now, both the equations will be a1 alpha square plus v1 alpha plus c1 equals to 0. We have put the value of x is alpha. Now, let us put the value of x in second equation. It will be a2 alpha square plus b2 alpha plus c2 equal 0. Now, we are solving these two equations by using cross multiplication method. Now, it will be alpha square. Now, try to hide alpha square. We can take b1 b2 c1 c2. The coefficient of alpha is b1 b2 c1 c2. Now, equal alpha. Now, we will hide alpha, take the coefficient c1 c2, after that a1 a2. Now, the constant part will be 1. Now, we will hide c1 c2, it will be a1 a2 b1 b2. Now, we can expand in this manner. We will first multiply left to right. It will be alpha square b1 c2 minus b2 c1. Now, alpha square b1 c2 minus b2 c1. In a same manner, it is alpha over c1 a2 minus c2 a1. Now, a1 b2 minus a2 b1. Now, alpha square will be b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. Now, we can find out alpha by taking last two. Alpha equals c1 a2 minus c2 a1 divided by a1 b2 minus a2 b1. Now, we can find out the condition in which the roots are common. Now, we will equalize alpha square equal alpha to the whole square. Now the value of alpha square is b1 c2 minus b2 c1 over a1 b2 minus a2 b1. It will be b1 c2 minus b2 c1 over a1 b2 minus a2 b1. Now the value of alpha is c1 a2 minus c2 a1 over a1 b2 minus a2 b1, c1 a2 minus c2 a1 over a1 b2 minus a2 b1 to the whole square. Now it will be b1 c2 minus b2 c1 over a1 b2 minus a2 b1, c1 a2 minus c2 a1 to the whole square over a1 b2 minus a2 b1 to the whole square. Now these two will be cancelled out. Now the value of c1 a2, now it will be c1 a2 minus c2 a1 to the whole square equal b1 c2 minus b2 c1 multiplied by a1 b2 minus a2 b1. Now this is the condition when the two quadratic equation which have one common root, so we can find out the condition of two roots to be equal. Now let us take some examples of the example number 1. Find the value of k if the equation 2x square plus kx minus 5 equals 0 and x square minus 3x minus 4 equals 0 have one roots in common. Now solution will be, let alpha be the common roots. Now it will satisfy both the equation. Now the equation will be first equation will be 2 alpha square plus k alpha minus 5 equal 0, and the second equation will be alpha square minus 3 alpha minus 4 equal 0. Now we shall find out this by using cross multiplication method. It will be alpha square k minus 3 minus 5 minus 4 equal alpha minus 5 minus 4 2 and 1 equal 1 2 1 k and minus 3. Now alpha square over minus 4k minus 15 equal alpha minus 5 plus 8 and 1 equals minus 6 minus k. Now alpha square minus 4k minus 15 alpha over 3 equal 1 over minus 6 minus k. The value of alpha square will be 4k plus 15 over k plus 6, and the value of alpha is minus 3 over k plus 6. Now alpha square equal alpha square, we will solve the value of k by using this one. The alpha square is 4k plus 15 divided by k plus 6, and it will be 9 of k plus 6 to the whole square. Now we can multiply 4k square plus 24k plus 15k plus 90 equal 9. Now the equation will be 4k square plus 39k plus 81. Now we are try to find out the value of k by using splitting of middle term. It will be 324 and the factor will be 2, 162, again 81, 27, 27 and 12. The factor will be 4k square plus 27k plus 12k plus 81 equal 0. Now we can take out the common in that. The common is k, 4k plus 27, and in last two terms 3 will be common, 4k plus 27 equal 0. Now the value of k is minus 27 upon 4 and minus 3. Now let us take another example. If a, b, c are positive real numbers such that the equation ax square plus bx plus c equals to 0 and bx square plus cx plus a equals 0 have common roots, then find the relation among a, b and c. Now in the same way as we have solved earlier question solution, let alpha be the common root so the equation will be a alpha square plus b alpha plus c equals to 0 and second equation will be v alpha square plus c alpha plus a equals 0. Let us try to solve by cross multiplication method. It will be alpha square b c c a alpha c a b and 1 a b b c. Alpha square equal ab minus c square and alpha equal cb minus a square and 1 of ac minus b square. Alpha square equal ab minus c square over ac minus b square and alpha is cb minus a square over ac minus b square. Now again alpha square equal alpha through the whole square. Alpha square is ab minus c square over ac minus b square equal cb minus a square over ac minus b square to the whole square. It will be ab minus c square of ac minus b square equal cb minus a square of to the square. It will be a square bc minus ab cube minus ac cube minus b square plus b square c square equal, now let us expand it, b square c square plus a to the power 4 minus 2a square bc. This go with this. Now it will be 3a square bc equal a4 plus abq plus acq. On dividing by a both side, it will be, the condition will be a cube plus b cube plus c cube equal 3abc. Now we shall discuss in quadratic equation. Now we shall start cubic equation. Cubic equation, it is in the form of a naught x cube plus a1 of x square plus a2 of x plus a3 equal 0, where a naught is not equals to 0 and a naught, a1, a2, a3 belongs to real numbers. So we shall find out the root of this cubic equation, and we shall find out the equation when roots are given. So first of all, we will discuss the relation between the roots of cubic equation and their coefficient. Let us take a cubic equation, relation between roots of cubic equation and its coefficient. Because as we know that it is a cubic equation, so there will be 3 roots, 3 possible roots. So we shall find out the relation between the roots and the coefficient of cubic equation. Suppose the cubic equation is a naught x cube plus a1 x square plus a2x plus a3 equal 0, and the roots of this cubic equations are alpha, beta and gamma. These are the roots of the cubic equation. Now a naught x cube plus a1 of x square plus a2 of x plus a3 equal a naught x minus alpha, x minus beta, x minus gamma. These two expressions will be equal. A naught x cube plus a1 x square plus a2x plus a3 equal a naught x square minus alpha plus beta of x plus alpha beta multiplied by x minus gamma. Now a naught x cube plus a1 x square plus a2x plus a3 equal a naught. Now we shall multiply these two brackets. It will be x cube minus gamma of x square, now minus alpha plus beta of x square minus plus minus multiplied by minus, it will be alpha plus beta of gamma x. Now alpha beta x minus alpha beta gamma. It can be written as a naught x cube minus alpha plus beta plus gamma of x square and alpha beta plus beta gamma plus gamma alpha of x minus alpha beta gamma. Now we can compare a naught x cube plus a1 of x square plus a2 of x plus a3 equal a naught x cube minus a naught alpha plus beta plus gamma of x square plus a naught alpha beta plus beta gamma plus gamma alpha of x minus a naught alpha beta gamma. Now we will compare the coefficient of LHS and RHS. First of all, we will compare the coefficient of x square. In LHS, the coefficient of x square is a1 and coefficient of x square in RHS is minus a naught alpha plus beta plus gamma. Now the value of alpha plus beta plus gamma is minus a1 upon a naught. We are writing this one is S1, sum of roots. Now compare the coefficient of x in LHS and RHS. The coefficient of x is in LHS is a2 and here the coefficient of x is a naught alpha beta plus beta gamma plus gamma alpha. It is a2 equal, that is your coefficient of x, a2 equal a naught alpha beta plus beta gamma plus gamma alpha. The value of alpha beta plus beta gamma plus gamma alpha equal a2 upon a naught. It can be written as S2. Now this will be the product, sum of product of roots. Now we can compare the constant part. Here the constant part is a3 and here the constant part is minus a naught alpha beta gamma. Now it will be alpha beta gamma equal minus a3 over a naught. It can be written as S3. Now if alpha beta gamma are the roots of this cubic equation a naught x cube plus a1 x square plus a2x plus a3 equals 0, then we can find out the sum and sum of product of two roots and product of three roots. Let us take an example of this one. So concept can be understand easily. Let us discuss an example. Find the value of alpha plus beta plus gamma and alpha beta plus beta gamma plus gamma alpha and alpha beta gamma if alpha beta and gamma are the roots of the cubic equation x cube plus 6x square plus 5x minus 12 equal 0. Now compare this cubic equation by a naught x cube plus a1 x square plus a2x plus a3 equal 0. The value of a naught is 1, a1 is 6, a2 is 5 and a3 is minus 12. Now, the value of alpha plus beta plus gamma is minus a1 upon a naught. The value of a1 is 6 divided by 1. The value of alpha plus beta plus gamma is minus 6. Now, we shall find out alpha beta plus beta gamma plus gamma alpha. It is a2 upon a naught. The value of a2 is 5 and a naught is 1. So, it will be 5. Now, we shall find out the value of alpha beta gamma, which is minus a3 over a naught, minus the value of a3 is minus 12. So, it will be plus 12 divided by 1. So, the product of root is 12. Now, in this class we have discussed about the sum of roots of cubic equation and product of roots of cubic equation. Now, in next class we shall discuss about the nature of roots of cubic equation and we shall find out the roots of the cubic equation. Thanks.